Okay, hello, I'm Juyoung Lee from KAIST, and I'm a PhD candidate. And today, in my talk, I will talk about interaction and the interaction, more specifically, initiation and selection for everyday XR. So this is the short overview of whole talk, and it will be gesture interaction for every day. So actually, we know there's a lot of interactions for the classes, and depends on that, we can do something. However, today, I will introduce three different interaction methods, what me and my co-authors published in few years, and I want to tell some alternative direction of the interaction for the everyday XR. So I will begin. So as all we know here, there's a lot of smart glasses, even from lightweight glasses to XR spatial computing devices. However, we all know they have advantage like everyday on screen, so we imagine wearing that in everyday life. But it should be different than now. Actually, it should be improved than now. So our mission is whip themselves into the fabric of everyday life, and following the Mark Wise is a great visionary. So there's a lot of companies really doing something here. However, even not only the company, but many enthusiasts to use that in daily life. We have to support these guys. So that's why my talk is about. So I want to help these guys to use the smart glasses more easy and more quickly. So the challenge we are facing is we don't have really, we have, but it's not perfect for this fast and easy selection, because fast and easy selection is essential to use in everyday life, because imagine there's some AI agent and I want to get some information from some object. I have to point out them. So do you want, how we can do that? We can do pointing, or maybe we can just say that I want to know that one. But maybe those things should be robust on false positive error, because we don't want to suffer from the false activation. And also, it should be socially acceptable, because I and we want to use smart glasses even talking with friends. And also, there should be compatible with long using device time, because we want to use every day, 24 hours, maybe about that. So that's the minimum what we need. And also, we need some kind of both. So here I am focusing on two things: shortcut launch and target selection. So there's a tons of possible solutions. So just ripping up, there's touchpad on the side, really traditional one, but it has limited input choices. And everyone knows you are doing something, so it is limited. And we have also hand gestures. But hand gesture is really good, and it is good for immersive experience, but actually it has some kind of social acceptability issue, because we cannot do that while walking. Maybe someone can do, but I don't want to do that. And also there's some tracking issues, because it depends on tracking quality, and it depends, maybe it will be really difficult to use in the outdoors or something. And also there's some raycasting. So it is quite good for selecting for distant object. But actually this is highly depends on the tracking quality, because small error from my side will be really big difference in the target. And so extra controller is really good. We all agree that, like VR and everything, but extra controller, we have to carry out that whole day is another challenge. So here, my key idea is like this. So first, for the self-sync, I want to introduce self-synchronous hot word gesture, which will be gesture version of the hot word, like for the voice assistant. And the key idea is more body parts means more intention. So if multiple body parts move synchronously, we can use that for the delimiter of the gesture initiation. And next, I will talk about the walling. Walling is a motion matching based input. Maybe some of you knows about the motion matching. So it is following the speed and phase. So briefly, so you have to follow what you see by your hand. And last is a really negative idea about the gesture marker is we also hold the maybe half of us using smartwatch here, maybe because we are in AW, most tech-oriented. So maybe we can use that for the input modality. So these three. So first, I will start for the self-sync. So first, self-sync concept is using only IMU. I don't want to use vision-based tracking because vision-based tracking has really bad on the battery consumption. So we can initiate with this one, then start some vision-based hand tracking. So actually, this video is to show you guys what I'm doing, but actually, I can really do with small amount of movement. Just 5 degrees is enough. But this one, I cannot show like if I do really small in subtle way, then you guys could not understand this. So I just do like hilariously. So this key idea is match your gesture carefully to make an input. So if it doesn't work, maybe you can just focus on matching a different body parts more. For now, let's imagine for the pinch gesture. If it doesn't work well, we have to do big, or maybe fast, or maybe change something. But here, we can only focus on matching ourselves. So it has quite easy to follow. So I will focus on telling the concept. So just briefly pass the overview. So get all the IMU from each devices. So I tested it with the glasses and watch and Android phone and collect all the IMU data and then put 2 thresholds. Actually, we can put some kind of fancy learning models, but here we want to just see it is applicable in real life, so just simplified. And then there are several experiments. Please visit my web to check all, but however, I will just introducing one experiment here is we also test about 2 things, hand and head and hand and leg. And also we have to test if it is applicable in obstacle tests. So we tested desk work, eating, or walking. So here we could get the accuracy and the false positive activation scores. So actually hand and leg was worse for the desk work because usually people sit on chair and maybe lean back. But the eating was lean forward, so maybe they have more freedom on moving hand, leg. And the good thing is that we could only get one or zero false activation and the speed. Speed itself, we can activate that from 3.3 seconds after watching the cue. So it includes the reaction time, like we have to think about visual cue and thing. So if we remove the reaction time, is just about less than 2 seconds. So this was good. And also to more detail, so we can easily, so now we have 2 thresholds. Usually for the gesture or something, we use root mean square to detect if I am moving or not, but we have another feature like correlation coefficients. So both can be used in handled by and for this system. So this is good point. So in conclusion, actually as all we know, the thresholding have trade-off for the false positive and true positive. So for false positive being low as a 0, if we want to keep no false positive, we could get 84% of accuracy. And if we want higher accuracy, 94% above, then maybe 2.1 false positive was occurred from the hand and head gesture. So this was the first idea, like initiation gesture, hot water gesture for gesture, hot water gesture. Yeah, so which is same as the voice interactions, hot word, like okay Google or hey Siri. So next idea will be a negative idea. So here we use IMU sensor data from smartwatch, but then we expand our thought, like we can also use touch screen on that. So I saw many companies trying to use gyroscope and the pointing. Actually, that's good, but we can also focus on the drawing on the touch screen, as we all familiar with the touchpad gestures. But here, what we need for the smart glasses is target selection. So we focus on the target selection. So we could make a marker for each button, then just draw that on the smart glasses. Then maybe less than 1 second to select something. So this is not a novel idea. This is idea from all the previous research. So there was some research about selecting by marking menu, and also there's a lot of research trying to use bezel-to-bezel swipe gesture. So we combine those for smart glasses users. So we designed mark with two types. One is B2B. So we was wondering, one complicated input is okay, or a combination of single input is better. So we compared that. So for more details, yeah, maybe so B2B, so it works like this way. Just see the screen and just follow the gesture. So actually, this is really easy. So we run the experiment with two different methods for single twice, for the swipe twice, and also B2B. Then also we give some feedback of the trace of the touch screen or not. And also we test with the seated position and walking position. So we collect all data, and for the result, we could get like B2B was the best, and the swipe then swipe twice, because in terms of time, swipe was better, but people do what they want to do. So the angle was not so accurate for the swipe. Yeah. So B2B, we have more information to fix that. So B2B was better. But however, just swipe once was okay, because people just do carefully for the first time. Maybe this is my assumption. Then second, maybe they do what they want to do. Yeah. So we hope gesture marking will be a complementary option for XR glasses. So last is the walling. It's motion matching based input. So this is ray casting, and here. So you just match speed and phase of the target. So this is also can be really small FOV, but just want to show you how to do that. Then we can finalize the selection. So this is also not a novel idea, but we imported that idea to the XR glasses, and we want to implement whole the interaction phase, because following the Donnemon's gesture research and thing, we have to get some feedback and we have to get some cancellation features. So we put this thing. So actually, this is not so complicated, but please ask me later. So we also test with the experiment. We compare with the ray casting with hand, because all we know is ray casting with hand is combination of pointing and gesture recognition. So it has quite worse performance compared to controller. So we compared that. and we compare in the two different distance, far and near. So what we got from the result is for success rate, raycasting near one was compatible with the walling near, and but when raycasting going further, when selecting distant target, this distant target was a 4.8 centimeter for 2 meter long. So that's not so small, but still the accuracy goes down, and also the completion time increased to 6.7 seconds. And also, we also checked the workload. And for the workload, we could find that raycasting far really goes crazy compared to other all conditions. And there's more interesting thing. So we use HoloLens for the raycasting hand. It has camera downward, but still as we all know, raycasting differs from the target. So when the target button is go lower, raycasting, the accuracy goes lower. However, our suggestion walling, there was no change. It was really stable for different display positions. And then following that finding, we also calculate the sensing FOV so how much FOV we need to select something. So here, we could find sensing FOV, walling is way smaller than the raycasting. Raycasting usually need about 50 degree of the vertical FOV, but it goes smaller when it's further because we set same absolute change, so it goes further, so it was smaller, but still much. So this is calculated by single input, then calculate the average. So this is not occurred by whole scene, but each trials. So for conclusion, walling uses smaller sensing FOV, but also shows stable result and outperform the raycasting for distance setting. So we suggest using walling for the distance smart target selection. Maybe it will be better, and it will be much more better for the lightweight AR glasses because they only have one RGB camera, or maybe we can replace that with the smartwatches because we only need some movement. So that's what we are continuing now. So for now, I introduced 3 different things. Yeah, and all our works is done by our group and co-authors, and thank you for the fundings. And if you want to see all the detailed info and published paper, just check my web. And this is summary, and I want to announce one more thing. So thank you for the whole funding until now, and I want to get some job opportunities if you guys can offer me. I would be really pleased about that. Yeah. Hey, thank you.
Big round of applause for Juyoung. Thank you. Now we have time for Q&A. If you got any questions, please step up to the mic. This is going to be the best way to ask. We still have 5 minutes for Juyoung to answer some questions.
Hi, my name is Namit. I wanted to ask a question, like how did you select, also it came in a little late, you may have mentioned this before, but I was wondering like how did you select the whirling motion and try to compare it with the touch sensing, and what other gestures you might consider in the future?
So touch gesture and walling is a bit different purpose. Yeah, touch gesture is more oriented to the fast selection but why we did walling is because touch need 2 hands.
Okay.
Yeah, but we want to also test the 1 hand. Yeah, so maybe we can use both at the same time. Yeah. For like I was imagining like quick for menu to the menu, like launching some app, maybe touch will be better, but the walling, works with the small, near distance or further distance. So we can, so another issue is selection for the plane is easy, but with the different depths is a bit struggling. So walling can be those kind of solution for that.
Okay. Well, that's great. Thank you.
Yeah, thank you.
Any other questions for Juyoung? That it touches a really interesting subject as to how to make the progress that we're doing in XR as invisible as possible, basically, right? Like your Ed Spool once wrote, good design, when done right, becomes invisible. And I think that that's where you want to head with this, right?
Yeah. Actually, I really imagine like it will be really cool if smart glasses detect my mind and just do every time by no delay and everything. But it is really difficult, so I really focus on some more explicit input. So we can help computer to say, yeah, the XR devices, like computing devices, not only just sensing me, but we can talk with each other. That's the basic, the theme of all this research. Yeah.
Any more questions at all? If not, we're good.
Thank you.
Thank you so much, Juyoung, for this great talk. Please give him a big round of applause.